put note 17. I think it should be notes 18. So I just don't know how to count there, guys. So what we're doing today is trig identities, Pythagorean trig identities, reciprocals, quotient properties, and you're going to see it's not that bad. You already know some of it, but you don't know all of it. So yes, you've been exposed to sine, cosine, tangent. Yes, you know the reciprocal properties. You know the reciprocal of cosine is secant, the reciprocal of sine is cosecant, the reciprocal of tangent is cotangent. And then if you're wondering, like, well, what are quotient properties? I don't see it anywhere here. Well, this right here is sine x over cosine x. This is sometimes called a quotient property. So if you were to go to Google and put quotient properties for trig, quotient just means that you have this ratio here. So quotient property of cotangent is cosine over sine. So that's just, and that's already something you guys know. At least I feel like we know, right? Do you guys feel like we know? All right, we're going to find out. All right, guys. So relax. What we're doing today, guys, is we're going to use trig identities, trig properties, to simplify and evaluate these expressions to prove that what they're saying. Like they're telling us here, transform sine x cotangent x into cosine x. So what they're letting us know is that sine x times cotangent x is sine x. So when you're doing a little proof or a little statement like this, I'll show you how to do it the right way, guys. So here we go. And don't worry, it's going to be simple. We look at this left-hand side. It says sine x cotangent x. And then I'm going to write sine x. There's nothing you can do about sine x. I mean, you can write the reciprocal, but don't. And cotangent x, instead of writing cotangent x, I'm going to write what? Yeah, the quotient property, cosine x over sine x. Now, what do you notice? So you're using skills that you've done like in 5th grade, 6th grade, 7th grade. So hopefully this will come natural to you. What do you notice? I have sine x times cosine over sine x. This is like sine x over 1, guys. Yeah, what cancels out? The sine x's cancel out. And notice all you have left with is cosine x. So we just proved this identity that sine x cotangent x is in fact just cosine x. Now relax. Tavis, do I just leave it like that? Whenever you're trying to prove something, guys, have you ever seen 3 little dots shaped in a triangle? Yeah, what do you think that stands for? It is literally, it's like saying in math, therefore. So when you're proving a statement like this, you can just write 3 little triangles, and you can just write sine x cotangent x, like so, equals cosine x, like that. And you proved it with the statement above, where you just have those sine x's cancel out, and all you have is that cosine x there. How do you feel? Okay, we wanted to start with that real quick. Actually, now that I'm thinking about it, I actually wanted to start with something else, but I already started, so we're just going to continue. Okay, now here comes the magic part. You guys ready for the next page? You're going to love this. At least I hope. I don't know. Here comes the unit circle again. All right. I know we've been in a pandemic, and there's a lot of skills that maybe we haven't gotten yet. In geometry and in Algebra 2, conics, we should have talked about a circle, equations of circles. And it's okay, guys. Don't worry if you don't know it. An equation of a circle centered at the origin always looks like this. And I'm going to put the note here, equation of a circle centered at origin. Does that look familiar to you? You can be honest, guys. No? Okay. It's okay. It's okay. It's just we've been in a pandemic the last 2 years, and maybe we just didn't get to it. In geometry and algebra 2, don't worry, this can go into a whole new lesson on its own, guys, but we're not going to go there. In geometry and algebra 2, let's say, I think in algebra 2, I think you probably proved this. So the unit circle has a radius of what? 1. So if I write x squared plus y squared equals 1, if I were to type this in Desmos, it will give me a unit circle. But if you wanted to type it into a calculator like an Inspire or a TI-84, they probably told you to isolate the y squared. And we're going to do both. You're going to see them real quick. So y squared equals 1 minus x squared. How do I get rid of that square here on the right on the y? Square root, y equals, now remember, every time you take a square root, you do plus or minus. And if I type this into Desmos, it will 100% give me a unit circle. So check it out. I'm going to take out Desmos. And here's my Desmos. And I'm going to click Graphing Calculator. Oh, watch it not work, right? It's going to work, I promise, 100%. Y equals, and then we're going to go square root. Where are you, square root? 1 minus x squared. Now, notice, I only get the top half. Why do I only get the top half? Because I'm missing the what? Yeah, the negative one, guys. If I put negative here, square root 1 minus x squared, look, you get your whole circle. Cool, right? I think it's cool. I mean, I don't know. All right, so there it is. And don't worry, guys. If you feel that we're weak with circles, we can always go into talking about different equations of circles centered differently in different locations. Oh, that's Camtasia there. Sorry, guys. That's what we're going to use to upload the video. All right, so there it is. So now we know the equation of a circle. So equation of the unit circle is x squared plus y squared equals 1. Are we still okay? Nothing crazy just happened, right? You guys told me that the radius was 1. All right. What have we learned in the first semester of the unit circle? So here is my unit circle. I'm just doing the first quadrant. You don't have to draw it super extreme. The radius is 1. Here's my angle. And this coordinate is some x comma some y. We're still all right, guys? Don't worry, I'm not doing anything that we don't know. I'm just drawing a right triangle inside my unit circle. This horizontal displacement is x. This vertical displacement is y. And then we did something called SOHCAHTOA. SOHCAHTOA. It's an acronym. What does it stand for? Yeah, S stands for sine, C stands for cosine, T stands for tangent. So from that, we say sine theta is equal to opposite over hypotenuse. Well, here's that angle. Opposite of that angle is a y. Y divided by 1, isn't that just y? So we're going to say that sine theta is y, and you guys already know this. And then for cosine, we're going to say that cosine theta is going to be x, because it's adjacent over hypotenuse. And then if you want, you can say tan theta is equal to y over x. Are we okay with that, guys? Okay. Now here comes the magic part. Don't worry, I'm going to slow down. I can see some of you guys writing really fast. You see that x squared plus y squared equals 1? I'm going to substitute these values in. And I'm going to write my very first trig property. Parenthesis, instead of writing an x, I'm going to write cosine theta, put the square on it, plus parenthesis, instead of writing a y, I'm going to write what? Sine theta. And I put the square on it, equals 1. Are we okay? All right. This is the most important Pythagorean identity. And we're going to lock it into memory right now forever. You guys ready? Valentine's Day is coming up, right? So you're going to tell your boy or your girl, we don't judge here, or, you know, whatever, them, or, okay. Anyways, you're going to write a poem or a letter to them on Valentine's Day, and you're going to go, babe, or whatever you call them, you are cosine squared, I am sine squared, and together we are 1. And if they don't get it, dump them immediately and upgrade. So tell me, what are you going to write? Okay, well, forget the babe part. Tell them, yeah. No. Well, but you got to put the square in there, guys. So let's do it again. You're cosine squared, and together. All right. If you want to do something, if you want to be a mega nerd, get some rings. One ring says cosine squared, the other ring says sine squared, and there it is. Like together, you guys are 1. Cool or not cool? Okay, common misconceptions real quick. Let's talk about those really fast before we continue. The squared, guys, you're going to see it like this. Cosine squared plus sine squared theta equals 1. Notice that the square is immediately after the s and not the theta. There's a reason for that. If you write cosine theta with a square on it, it is not the cosine that's being squared, it's the argument, which is theta. Does that make sense? Okay, so what I'm trying to say is this. I saw something that said no. If I write cosine theta and I put a square on it like this is equivalent to saying cosine, put the square after the s, theta. If you write this, cosine theta squared, where you're telling me is that it's the theta that is being squared and not the cosine. Does that make sense? So from now on, you're going to see that squared immediately after the s. Are we cool? All right, so here we go. The most important property is this one. I'm going to put a bullet on it, and I'm going to write cosine squared theta plus sine squared theta equals 1. We're going to derive the next two properties. Now, I hope that others are doing this, guys. I believe in this. This is not the first time I've told you guys this. I want you guys to see that all these formulas come from somewhere. We're not just giving you formulas. Notice that we're deriving them all. And you should always question, like, where does this come from? Why is it? So here we go. I'm going to take that cosine squared plus sine squared equals 1, and I'm going to divide all three terms by cosine squared. So I'm going to rewrite it again, guys, because I want to put all my important ones with the bullet. So I'm going to write cosine squared theta plus sine squared theta equals 1. And I'm going to divide all three of these by what? Cosine squared. And I'm going to get a new property, a new identity. Cosine squared over cosine squared, that is 1, plus sine squared over cosine squared, that is, what's sine over cosine? Tan, but there's a square on it, so I got to write tan what? Squared. And then what's 1 over cosine? Starts with an S. No, not sine. Secant, but there's a square on it, so I got to write squared. This is your second property. So I'll put this as your second bullet and write 1 plus tan squared equals secant squared. Are we okay so far? Take a guess. I'm going to use the same formula, cosine squared plus sine squared equals 1. And instead of dividing everything by cosine squared, I'm going to divide everything by what? Take a guess. Yeah, by sine. Divide everything by sine squared. That's a square there. It just looks like a 2 theta there. So let's see. Cosine squared over sine squared, that is going to be cotangent squared. Remember that cosine over sine is cotangent. Plus sine squared over sine squared, that's going to be 1. And 1 over sine squared, that's going to be, starts with a C. Second letter S, cosecant squared. This is your third. So I'm going to write cotangent squared plus 1 equals cosecant squared theta. We got all three from the first one, cosine squared plus sine squared equals 1. Now, I call it, in this room, I call this the Valentine's formula. If you go out to the university, don't tell the professor that it's the Valentine's formula. The official name is called, what do you think it's called? Pythagorean trig. Pythagorean trig identity. So if you were to go to Google and you put Pythagorean trig identity, this is what it would spit out. How do we feel? Do we feel okay, guys? Okay. Now, I'm going to take a little moment. I wanted to do this in the very beginning of class, but in case you're wondering, like, Chav, when am I ever going to use this? When am I ever going to, like, I'm learning about these sines and cosines and tangents, and my parents haven't used sine, cosines, and tangents. When am I going to use them? All right. Real quick, go to the very last page. It's, yeah, the very last page. I took this from, let's give full credit. I took this from Ohio State University. It was a PDF. It was called Lecture 8, and it didn't have a classroom title. It just said electrical engineering. If it would have had a professor, I would have put the professor's name. But there it is, full credit to Ohio State University. This is an ROC circuit. It's a second order differential equation. Hopefully you have some experience with this. This is a resistor. This is called an ohm. This is a switch. This is called a capacitor. The units of a capacitor are in farads. Another resistor, and this is an inductor. At the high school level, you probably will not see an inductor because that requires calculus knowledge. So at the high school level in physics, you will probably see this semester circuits with resistors and capacitors. And I want you guys to notice, Chavez, when am I going to use sine, cosine, tangent, and all? Well, look at this solution right here. It's finding the current, and I want you to observe that there's a cosine and a sine. And the reason for that is because this current here, guys, is AC and not DC. So AC is a wave. It's a wave. It's out of phase with voltage, I think 90 degrees. Don't quote me on that. Ask Mr. Winters. But there it is. So sine and cosine, look at these skills that you need. So we're just at the beginning, guys. We're just at the surface for the skills that you need to be able to tackle questions like this. Does this look scary? It's not scary, guys, trust me. Once you know enough, it's not that bad. You need to know a little bit of calculus. This is telling you that the current with respect to time. But we're not there yet, guys, so don't worry about it. But this is why we're doing what we're doing. These are the minimal skills. So if you want to be an engineer, like this is where it starts, right here, guys. So make sure that you're on top of your game. There we go. I'm glad I said that. I think we're good now, right? I hope. All right, guys, let's go to example 2. And hopefully we'll have some fun with this one. So this one says, and don't worry, we're going to get more experience. Transform cosine squared minus sine squared into 1 minus 2 sine squared. You guys ready? So I'm going to write cosine squared x minus sine squared x. And then I'm going to be like, well, what do I do now? So we're going to make some side notes of some stuff that we just learned. We just learned it right now. Side note. What did we just learn right now? What formula? Yeah, the Valentine's formula. What was it? Perfect. I can make that argument whatever I want. I put an x instead of a theta. Are we okay with that statement there in the side note? All right. So notice that I want to transform into 1 minus 2 sine squared. Do you see any cosine squares? No. So that means it gives me a hint that I'm going to use this side note and I'm going to get cosine squared by itself so I can substitute. Does that make sense, guys? So I'm going to move that sine squared to the right. So from my side note, I can say that cosine squared x is equal to 1 minus sine squared x. Does that make sense to you guys? Perfect. Then for good notes, I'm going to come over here and I'm going to write using side note, substituting cosine squared x equals 1 minus sine squared x. I'm just rewriting this statement right here. So instead of cosine squared, you know what? Let me rewrite it. It's fine. It's fine. I think we're good, guys. I'm going to go ahead and isolate it first so you guys can see what I'm doing. So instead of writing cosine squared, what am I going to write inside of that? 1 minus sine squared. All I'm doing is substituting, guys. Substituting the cosine squared with 1 minus sine squared. Is everyone okay with that? Okay. And I did forget the sine squared there. There it is. Have I made any mistakes so far, guys? Yeah, let me know. I make mistakes all the time. There's nothing in front of those parentheses. Can I just drop them? Yeah, there's nothing in front. If there was something in front, you would distribute. But there's nothing in the front, so we can just drop those parentheses. 1 minus sine squared x minus sine squared x. And then how many sine squared x's do you guys see? So I'm going to write equals 1 minus 2 sine squared x. How do we feel? Is that what we were trying to prove? Yes. I'm going to do 3 little dots in the shape of a what? triangle, and I'm just going to write the very first statement. Cosine squared x minus sine squared x does in fact equal 1 minus 2 sine squared x. You only use the dots when we're trying to prove a statement, which that's what we're trying to do. How do we feel, guys? Sorry. Are you guys all right with that? All right, let's go to the next one. Don't worry, guys. We're going to give you guys a chance to practice a whole bunch in a little bit. Example 3. Prove algebraically that 1 plus cosine x times 1 minus cosine x equals sine squared. Okay. Y'all ready? All right, so here comes your skill from Algebra 1. What do you think feels right to what? Oh, it's already factored. To distribute or FOIL? Yeah, don't worry. You need more experience. I get it that this is brand new. What's 1 times 1? 1. What's 1 times negative cosine? Negative cosine x. What is cosine x times 1? Plus cosine x. What's cosine x times negative cosine x? Yeah. When you say the squared, guys, say it after the cosine. Cosine squared x. Because if you say cosine x squared, that means the x is being squared. Are we still okay, guys? What zeroes out? Yeah, the cosines. There's a negative cosine and there's a positive cosine. 1 minus cosine squared x. That's actually the answer, guys, but you need a little assistance. You got to put side note on the side. And the only formula we know is Valentine's formula. So I'm going to write cosine squared x plus sine squared x equals 1. And then that says 1 minus cosine squared, right? So look, check it out. I'm going to go ahead and move that cosine squared to the right. And there's other ways. You don't have to necessarily do it just this way. 1 minus cosine squared x. OMG, look at that. 1 minus cosine squared x equals sine squared x. Do you guys see that? So then I'm going to make a side note, and I'm going to go using side note that sine squared x equals 1 minus cosine squared x. I know that 1 minus cosine squared x must equal sine squared x. Does that make sense? And there it is. You gave your professor or your teacher all the work. You noted your side note. Using your side note, you're using that. And now I do what? 3 little dots and a triangle, and you just make your first statement true. You're going to say 1 minus cosine x, 1 plus cosine x does in fact equal sine squared. How are we feeling, guys? Now, do you have to do this all the time like this? The answer is no. If you recognize, but you got to recognize it, and this only comes with experience, guys. You got to do a whole bunch of these questions and be all about math life all the time. If you recognize that this is the difference of squares, you could have immediately written 1 minus cosine squared. Do you remember your difference of squares rules, guys? A minus b, a plus b. That is the difference of squares, a squared minus b squared. So if you would have recognized that, you could have gotten right to that. Are we feeling okay so far, guys? Okay. All right. Don't worry. We're gonna get more fun ones. We got 2 more, and then we're gonna make you guys come up and all that good stuff. So it says prove algebraically that cotan A plus tan A equals cosecant A secant A is an identity. Y'all ready? I'm looking at the left-hand side. We don't have to. We could always look at the right-hand side, but I'm looking at the left-hand side. And I want to prove that that is the right. So I'm going to write cotan A plus tan A. Now, we're going to go back to sine and cosine. Cotangent is what? Look at your first page of the notes. It's which is the same thing as cosine over sine, guys. I heard this table also say it. So I'm going to write cosine A over sine A. This is cotangent. All right, plus, what is tan A? Someone from that table in the back. Yeah. Sine A over cosine A. This is tan A right here. Now let's go back to 5th grade. When your teacher told you 1/3 plus 1/4, how did you add fractions? You needed to find a common what? That's the same skill you use right here, guys. I have a sine A on the left-hand side. I have a cosine A on the right-hand side. So I need to find a common denominator. Multiply the right term by sine A over sine A. Notice that I am changing colors. So if you have coloring pencils for good notes, this will be a good time. On the left-hand side, I'm going to write this one as, I'm going to multiply that by cosine A over cosine A. And I'll wait for you guys. Are we okay? Put in there that you're finding common denominator if you don't have colored pencils or anything. So now you're going to have this. Cosine times cosine, that is going to be cosine times cosine? Cosine squared. Cosine squared over, and I'm going to write the sine A first. Sine A cosine A plus sine A times sine A. What is that? Sine squared over, and I'm going to write the sine A first. Sine A cosine A. Are we still okay? Are my denominators the same, guys? Heck yeah, they are. So here we go. Cosine squared A plus sine squared A over my one common denominator, sine A cosine A. Chavez, that doesn't look like that cosecant A, secant A. Well, we're almost there, guys. Relax. What do you notice in the numerator? Is that something? Is that an identity? Yeah, what is it? It equals 1, because we proved that. Valentine's formula, right, guys? Cosine squared plus sine squared, that's just 1. So we're going to write 1 over sine A over cosine A. Charles, that's still not the answer that it says. Well, relax, guys. We still need to do one more step. We can break this fraction up, 1 over sine A cosine A, into 1 over sine A times 1 over cosine A, can't we? Yes. And what is 1 over sine A? Cosecant. What is 1 over cosine A? Yeah, and look at that, guys. Cosecant A, secant A. And this starts to become fun because it's kind of like a little puzzle. Do you guys see how we got there? And now that's the last statement. So now what do I do? Well, it's the second to the last statement. My last statement is going to be what? The little triangle with 3 little dots. And then I'm gonna write cotangent A plus tan A definitely, in fact, is cosecant A, secant A. And it's up there, all the work that we did to get to that point. Cool or not cool? Yes, please. If it says prove algebraically that something equals something, they're not tricking you. They're telling you that it is. If they're telling you that it prove that it is not, then no matter what edit you do, you won't be able to get to that property. Does that make sense? So they'll never try and trick you, unless it's an error by my part or something. How do we feel, guys? Now, when you log into UH, they're not going to tell you to prove. It's just going to say, here's a whole bunch of answer choices. This is equivalent to what? When you take it's going away, but I don't know if, do you know, Ms. McLaren, if the SAT math is still a thing for future no? I believe the SAT math is going away, guys. It's a level 2 one. The level 2 is what has trig identities, a lot of them too. If you are lucky to take the level 2 SAT math, that has a lot of these. And don't worry, it's very basic. You have a whole bunch of answer choices. They just tell you this expression is equivalent to, and then you just choose the one that's equivalent to. And if you want, we can do some practice SAT problems here, guys, if you're studying to do the level 2 SAT math. All right, this one here is hard, but it's only hard because we don't have the experience yet. And don't worry, we're gonna maybe we'll take a brave soul and see if they can do it a different way, and we'll see. So it says prove algebraically that 1 minus cosine b over sine b is equal to sine b over 1 plus cosine b. We want to prove this. And at first glance, you're like, man, where do I even start? I guess, we've been looking at the left-hand side all this time. We don't have to do the left-hand side all the time. So we just have this, 1 minus cosine b over sine b. So it's only tough because, like we said, we don't have enough experience. But we will. So the thing to do, how to do this, guys, is we got to be smart. Right, oh, yeah, there it is. So we got to multiply this by a 1, but a smart 1. So we're going to multiply by 1, but a smart 1. So the smart 1 to do, we have two choices, and both choices are correct. It doesn't matter how. We can either multiply this by sine b over sine b, or we can multiply this by the conjugate, the binomial conjugate, not to be confused with the complex conjugates. The conjugate of 1 minus cosine b, which is 1 plus cosine b. Okay, hold on. You guys are looking at me like, do you guys remember what conjugate means? Oh, okay. When you were in Algebra 2 and you had something like 1 minus 3i, and your teacher told you, give me the conjugate of this. Do you remember what the conjugate of 1 minus 3i was? Perfect. 1 plus 3i. So you guys do remember. Conjugate means whatever you have that is different, that is not your integer. Like if you have this imaginary part, you switch the sign, the opposite. So 1 minus 3i, the conjugate, 1 plus 3i. So if I have something like 1 minus cosine b, if you want to be specific, the professor will probably just say the word conjugate, but he or she should be saying binomial conjugate, because there's two terms. 1 minus cosine b, the binomial conjugate is 1 plus cosine b. Does that make sense? Now, why is multiplying by a conjugate, why does that come natural to math people? Let me tell you why. Because when I multiply by the conjugate, and I'm not saying this is the only way to do it. You could have multiplied by sine b over sine b. When you multiply by the conjugate, what you're really doing is, look, that's the difference of squares. And every time you do the difference of squares, you get, in this case, we get a property, which is what we wanted. So that's why this multiplying by conjugates comes natural to mathematicians, because they get a property that they want. Does that make sense, guys? Okay, so there we go. I'm going to multiply by the conjugate of 1 minus, and don't worry, we're going to show you a different way. We'll probably show you 2 different ways, or 3 different ways. Are we still okay, guys? No, before I continue, because I don't want you guys to be a robot. Do you notice that this is just 1? And anytime you multiply anything by 1, do you change it? No. So be very careful to not be a robot. You can probably trick some teachers, but I'll eventually will catch on. Don't be a robot, guys, because you guys are really good at listening instructions and going, oh, step 1, step 2, step 3. I'm just doing that. And when they ask you, like, why did you do the steps? I don't know. Chavez did them, so I'm going to do it. So make sure you understand the why, like why we're doing this. Cool? All right. Sorry, guys. Just wanted to go off of there on a little tangent there. When I multiply the top, 1 minus cosine times 1 plus cosine, you can FOIL if you want, but we already know that's the difference of squares, correct? So I'm going to write it as 1 minus what? Perfect. And on the bottom, don't distribute. Leave it like this. So catch up to there, guys. Are we okay so far? All right. From there, do a side note on the side somewhere. And we're going to write what formula again? The Valentine's formula. Tell me the Valentine's formula, Barrera.
Cosine squared x.
Or B, yeah.
Plus sine squared b.
Perfect. I notice that I have a 1 minus cosine squared b in the top. So that's what I want to get on my side note. I'm going to move that cosine squared to the right, and I'm going to write sine squared b equals 1 minus cosine squared b. Are we still okay? Using that side note, so I'm going to go using side note. I'm going to substitute the 1 minus cosine squared on the top. So I'm going to write sine squared b over sine b parenthesis 1 plus cosine b. Are we still okay, guys? What's up?
Why don't we do cosine to the right side?
Oh, because I'm trying to get 1 minus cosine squared. I'm trying to get an expression 1 minus cosine squared. And when I move it to the right side, I get exactly that, 1 minus cosine squared. You know what I mean? Right. Notice we're really close to the answer. I have a sine squared in the numerator, and I have a sine b in the bottom. Can I cancel those out? Can I cancel those out? Yeah, you can. You can. Those you can. And then you're left with what? Is that what we wanted? Sine b over 1 plus cosine b. And there it is, guys. So I'm going to put 3 little dots. And I'm going to write 1 minus cosine b over sine b equals sine b over 1 plus cosine b. What do you guys think?
Wow.
Is that cool?
Yes, that is true.
Do you guys want to see an alternate method?
I don't know. I feel like I kind of got the picture.
No, because I want to show you guys that it doesn't matter what you do. If you're doing it correct, you will be right no matter what. Alternate method. What's your favorite color? Well, actually, choose between blue and green. Okay, green. Alternate method. Don't write this down. Just look so you guys can see. If I would have started with 1 minus cosine b, let's say I didn't know about the whole conjugate stuff. And I'm like, well, Chavez says that I got to multiply by something, a smart one. I'm going to multiply this by sine b over sine b. Let's just start. I don't know. Let's see what happens. So then I'm going to get 1 minus cosine b. Don't write this down, guys. Just listen. I haven't done this. I haven't started this. So who knows? Maybe I won't get it right. So I have 1 minus cosine b over sine squared. No, it looks like it's going to work. And I'll show you why right now. So then you get to here and you're like, well, now I'm stuck. Well, as soon as you see sine squared, you're not. Use your Valentine's formula. So side note again, I come up here and I'm going to write cosine squared b plus sine squared b. Doesn't that equal 1? So I'm going to move this cosine squared b to the right. So I'm going to write sine squared b equals 1 minus cosine squared b. And at first you're probably like, Chavez, you're not going anywhere with this. It looks like you're going to get stuck. Well, let's see. I'm going to write parenthesis 1 minus cosine b. And I'm going to put the sine b there. And on the bottom, instead of writing sine squared b, I'm going to write what? All right, let's see if we really are stuck. Do you guys recognize that 1 minus cosine squared b is the difference of squares? Do you guys know what I mean by difference of squares? I mean this, that in the bottom, 1 minus cosine squared b, I can rewrite this as 1 minus cosine b times 1 plus cosine b, can't I? And on the top, I still have that 1 minus cosine b, no?
Oh.
What can I cancel out? 1 minus cosine b's, they cancel out, and look what you have left. Is that what they wanted me to prove? So it does not matter how you start. If you understand the logic, if you understand the identities, you will get to the right answer. Cool or not cool? So what we're going to do right now, guys, we're going to do an activity. I would like for you guys to work in groups, and then we're going to call each group up one at a time to work out the problem. So make sure you know it as a group, because then the class is going to be able to ask you questions, and I'm going to ask you questions, and all that good stuff. Does that make sense to you guys? And no big deal. Just like we've done before, you guys know how to use this.